Hello everyone, it's the electronic engineer here again. In this video, I'll be showing you a video of a guy that was simulating a circuit, and the circuit he did, it worked from his end, but actually it won't work. Yeah, it won't work. So just sit tight, watch the video, and drop a comment to tell me why the circuit didn't work and to tell me about my adjustment I made. So in this video, I made a little adjustment to the circuit the guy did and the explanation of the circuit I did. So let's get started. Sit tight. Don't forget to like, share, and subscribe as well to get more updates. All right. So I found the circuit online when I was scrolling down my YouTube page, and I was like, oh, well, let me try it out because I was actually working on a solar charging circuit. So I found this and I was like, oh, let me check it out. So the video we just watched was actually a video of the guy simulating the circuit using proteus. All right. So I decided to try it out, and this was my result. So when I tested the circuit, there was no output. Like it just didn't work out, and I was like, what happened? So the guy, I don't know the magic the guy did there, but this thing cannot actually work. The reason is that this diode here does not have a part because this capacitor here will block the DC voltage coming from the solar panel. So how did it work in the guy's video? So that I don't know. And of course, this guy here will actually block this diode here will actually from the connection will block voltage from entering into the battery. So how will this charge the battery? I was like, oh well, this will don't come again. Okay, so um in aspect to that, I did my own circuits from the guys. This I discovered that he used LM317T, and when I checked the database, it was actually the data sheet rather. It was actually a 1.5 amps voltage regulator than the usual what's it called 7805 and 06 series. All right, so that was what I used to actually design the circuit. Now from the design, well, I have my solar panel here. I have my input diode, which allow current to flow in only one direction. I have my indicator LED here to show if the solar panel is supplying enough voltage. Now I have this voltmeter here to record the input voltage to the voltage regulator. I have this capacitor here to actually help to remove the sudden increase and decrease in the input voltage. All right. I have now that's for the primary aspect. Now for the secondary sides, I have this my biasing resistor. Okay, I have my potentiometer here, which I can use as a voltage regulator to regulate the output voltage. I have the output diode here, which is this guy here. The output diode is just to allow current to flow in one direction and prevent the battery voltage from going back into the system. Okay, so I have my battery here, 9 volts battery, power that will be charging by 12 volts 12 volt solar panel. So I have this capacitor here to actually reduce the rate at which the voltage changes when I'm operating my potentiometer. Okay, and I have this my voltmeter here to record the output voltage. All right, so let's test the circuit, and I'll zoom a little into the system. All right, now the circuit is up and running. As you can see, the solar panel, a 12 volt solar panel, because of this diode, which actually provided a voltage drop of 0.7, the voltage dropped to around 11.3 volts, and this red LED indicates that okay, the system is working. All right, so moving on to the secondary side, that's what I want to focus on. Moving on to the secondary side, um the output voltage is 9.444 rather. All right, so I can actually decrease the voltage by using the potentiometer, as you can see from there. Now the reason why it is slowing down rather than fast is because of the capacitor. All right, because of this because of this biasing capacitor I'm using, that's why the voltage does not slow down, that does not decrease immediately with immediate effect. Rather, it takes some time before it drops, reason because of the capacitor. So it depends on the capacitor time of charge and discharge that will determine the rate at which the voltage will increase and decrease. All right, so this was my circuit, and it worked just fine. So I can use this circuit also to charge maybe a smaller battery, maybe like a lithium battery that has a voltage of 3.7 volts. I can use it to charge a 4 volts battery. I can use it to charge a 6 volts battery. All I need to do is just to regulate the voltage, the output voltage. Now for a 6 volts battery, I think I should leave it at 7 volts and it should be up and running. All right, guys. So this is my circuit compared to what the guy did. Compared to what the guy did, yeah, I don't think that will work. All right, thank you very much.